So I think one of the things that's really exciting about the 10th anniversary of CRISPR is that there's been a ton of progress in a relatively short amount of time compared to other emerging technologies, whether that's moving things closer to the clinic or further developments of the technology itself. And I think what's super exciting is that it's still really early days in terms of the potential. So we've made a ton of progress in CRISPR, but I would say we're still at that early inflection point where really there's just so much more potential for the technology to have a positive impact on patients' lives over the next 10 years. And that's only compounding as the technology develops. So there's been a lot of really transformative work, obviously, with proteins like Cas9. At Mammoth, we're really excited about expanding the potential of CRISPR, though, with these non-Cas9 proteins. So really looking at the diversity of life and the entire kind of universe of CRISPR. And at Mammoth, we've been able to really find and characterize these brand new CRISPR technologies like Cas14 and Cas and really what these are doing is enabling the potential of CRISPR to expand further, whether that's CRISPR-based diagnostics or these entirely new fields and new applications of CRISPR that no one expected, or that's really pushing forward things like in vivo therapies, right? And really going towards these ideas of permanent cures for genetic disease and moving beyond even treatments. So I think these are all things that are really exciting that are enabled, especially by these novel CRISPR technologies like the ones that we're pioneering at Mammoth. A lot of the field's been focused ex vivo, for example, because that's definitely a bit of more low-hanging fruit in terms of accessibility. I think at Mammoth, one of the areas we're excited about is really going in vivo. So really taking these technologies and pushing them forward. For example, with these ultra small systems that we've pioneered at Mammoth, where Cas9 can be around 1,400 amino acids, and these ultra small systems can be a third or less the size. And that really opens a lot of different doors for delivery, whether that's viral or non-viral, in terms of the capabilities of getting this technology where it needs to go in the body. And I think that's a space looking at the next 10 years that we're incredibly excited about and has a huge amount of potential. So I think the story of the next 10 years is definitely going to be one about pioneering forward these applications that are a little bit less of the low-hanging fruit. And that's what we're excited about at Mammoth in particular as well. So we're incredibly fortunate, obviously, to work with Jennifer, who's pioneered the CRISPR technology and won the Nobel Prize for her work pioneering the technology in 2020. And I think I've never gone wrong in my career and working with people that are smarter than me and really passionate about what they do. And I think that's good for the entire co-founding team, including Janice and Lucas, who were in Jennifer's lab. And then, of course, the team of 150 plus people now that we have at Mammoth. And I think that's one of the things that makes CRISPR special, right? Like anytime you have one of these emerging technologies, I think what really signals the potential of it is the people that assemble around it. And that's what gets me out of bed every day at Mammoth. And so we're incredibly fortunate to have Jennifer and, of course, the rest of the team supporting us on this journey to really bring CRISPR to that next level and this kind of next generation of products, whether that's diagnostics or that's like in vivo therapeutic. Yeah, so since the very beginning of the company, we've had this thesis that by unlocking novel CRISPR technologies like these ultra small nucleases or these diagnostic applications or beyond, that we would be able to build either new products or improved versions of existing things that people have been working on, like therapies. And in our back pocket, of course, we already had things like CRISPR-based diagnostics and some of these ultra small systems. But I think in general, it's really just about making sure that we're pushing everything forward as fast as possible. So early on in the company, we talked obviously a lot about the exciting new CRISPR-based diagnostic applications. And more recently, we've been public about some of the therapy applications, but definitely we've always been excited about the kind of full breadth of potential that these proteins have. Because CRISPR is one of these unique platform technologies, right? And it's a platform both within these areas of you can program it to go after thousands of diseases, thousands of things you want to detect or cure. Also, zooming back out, like across different areas, right? And it's not even just therapeutics and diagnostics, although those are the places that we focus a lot internally, but, agriculture, biomanufacturing, and many other industries. But as anyone that's built a startup can tell you, you have to make sure that you're focusing on the right things at the right time and doing everything in the kind of most powerful manner possible to get to patients as quickly as possible. So since, again, the early days of the company on the diagnostic side of the business, we've really been talking a lot about this idea of why do you have to make this choice between centralized ultra high accuracy or decentralized less accurate testing, right? So, PCR versus like antigen antibody testing. And we've always had this thesis that CRISPR-based diagnostics can really punch through that dichotomy, and across the whole spectrum from the lab all the way to the home has a lot to offer in terms of enabling new types of ultra high accurate diagnostic testing. Obviously, when the pandemic came on, we never could have predicted that, but it really showed this thesis, right? Of like, it's 2022 now, and why do we have to make these choices around accuracy versus accessibility? So the pandemic definitely accelerated a lot of our work on the diagnostic side, but our thesis has always remained the same. And we were very fortunate to be able to work with the FDA to get, for example, emergency use authorization that showed, really the power of this technology. And even within just a few weeks of the pandemic, we worked with Charles Chu over at UCSF, for example, to spin up a CRISPR-based way of detecting the novel coronavirus. So I think it's really showcased the potential and the power of CRISPR-based diagnostics, but the thesis has always been very, very much the same. Yeah, so first of all, it's incredibly exciting actually to see companies across the CRISPR space making advances towards the clinic. And I'm definitely a big believer that a rising tide lifts all boats in that regard. I think that there's so many diseases that CRISPR has the potential to transform patients' lives. It's definitely not a zero-sum game, no question at all. That aside, I think one of the things that really differentiates Mammoth is really building out the next generation CRISPR toolbox itself, right? And that means that we have, a hammer, we have a screwdriver, we have a wrench, and we've built what's become the most diverse toolbox of CRISPR systems on Earth, right? And some of the heroes of that toolbox are things like, Cas14 and Cas5, but there's many others that, we aren't even public about. And I think that is a really powerful spot to be, because it means then we can say, what are the really high need diseases where maybe technologically we weren't able to go there, especially, things like permanent cures and in vivo treatments. And we can choose the right tool for the right job rather than like, we have a tool, and we have to kind of stare at everything until it kind of looks like a nail with a hammer, I think that's a very powerful concept. And that's something that we continue to push the envelope forward on, whether that's, new nucleases, of course, or that's what we call CRISPR plus. So that's combining the CRISPR technology with, activating or inhibiting or base editing or writing or all these other, potential ways of, once you've sent protein somewhere in the genome, actually, either changing it or turning something on or turning something off, and really staying at the forefront of both research and kind of CRISPR technology development, but also pushing forward to the clinic. I think that's one of the things that makes Mammoth super unique, is really staying at the front of both of those. So I think on the diagnostic side, that's incredibly exciting because we're already starting to see it get close to patients, right? And I think some of the first ways people might interact with CRISPR would be on the diagnostic side, which is like pretty crazy to think about, given that this is a field people weren't even really thinking about before Mammoth came along. So then on the therapeutic side, I think a big part of what we see as the future of kind of CRISPR-based therapies and gene editing is permanent cures. And that's where we really are pushing the envelope in terms of what can be done in vivo. And it comes down to what you mentioned, which is new capabilities, right? So whether it's being ultra small systems, so you can enable different ways of doing delivery, or that's other properties that can be powerful in terms of patient impact. That's what matters at the end of the day, right? And that's what we're really focused on. So at Mammoth, we really think the power of CRISPR is the find and search functionality. It comes with a free pair of scissors, but you can use them or not use them. What makes CRISPR so transformative is the fact that it's this programmable kind of molecular machine that can go bind to any DNA or RNA in a very reproducible and effective way, right? And you can use the scissors or not use the scissors. You can fuse a protein to it or not fuse a protein to it. We think there'll be thousands of different methods, cut, paste, delete, insert, there's thousands of different things, right? And there's always going to be another one. And that's super exciting, right? But they're all going to be leveraging this fundamental search and find capacity of CRISPR. And that's at Mammoth what we're super excited about. For example, with having, ultra small systems, that means that you have all this other room for putting all these other functionalities on it, right? And that's where we think that we can really sit at the middle of this, what's probably going to be an explosion of exciting new ways of leveraging these fundamental kind of CRISPR nucleases to do these additional functionalities. And that being said, sometimes cutting is going to be the best thing to do, right? It's going to be dependent on the disease. And that goes back to this philosophy of, having the most diverse toolbox possible and just choosing the right tool for the right job, and not, trying to crown one of these methods necessarily king of the hill, right? And all disease is going to be this or that. No, it's going to be different for every disease, right? And you want to be driven by the biology, not necessarily by whatever, one tool you happen to have access to. And I think that's what we're really excited about Mammoth is, once you have this toolbox, then you can really start kind of tackling a breadth of disease and really going after these kind of holy grails of things like permanent cures and diagnostics. Yeah, I think it's an incredible argument for basic research, right? It's not so basic at the end of the day. But yeah, people often, wonder why do we explore microbes or, why do we do this or that or the other thing? And I think, that's just kind of in the human spirit of discovery. But even if you discount that, I think that, time and time again, there's so many examples of cases where technologies that are, transformative on our lives and on our health have really come out of very surprising directions. And you wouldn't have been able to probably predict it beforehand.